Section 6.2, Properties of Parallelograms. By the end of this lesson, you should be able to use properties of parallelograms. We had a sketchpad lesson, and from our sketchpad lesson, we should have noticed that a parallelogram is a quadrilateral that has both pairs of opposite sides that are parallel. So in our diagram below, we can say that these sides are parallel and these are parallel. By definition, that is what makes a parallelogram a parallelogram. We had 4 properties of parallelograms that we should have identified from our sketchpad activity, but let's review them here. Our first property of parallelograms is that a parallelogram will have both pairs of opposite sides congruent. So looking at our diagram, we can see that QR is congruent to PS and QP is congruent to RS. Our next property of parallelograms is that opposite angles are congruent. So looking at our diagram, angle P and R are opposite angles, and so they're going to be congruent. And Q and S are opposite angles, so they'll be congruent. Third property of parallelograms is that if a quadrilateral is a parallelogram, then consecutive angles are going to be supplementary. So what does this exactly mean? Well, if we're looking at our diagram below, we might have angle P be, let's just say angle P is a measure of 30 degrees. Well, angle S then will be a measure of 150 degrees. Also, we can say that angle Q then, because opposite angles are going to be congruent, is 150 and angle R is 30. Let's move this over. And anytime you have angles that are consecutive, meaning that they're right next to each other within the interior angles, they'll be supplementary. So looking at Q and P, they're consecutive, they both add up to 180 degrees. Q and R are consecutive, they'll both add up to 150 or 180 degrees. R and S are consecutive, once again they add up to 180 degrees, meaning that anytime you have consecutive angles, they're going to be supplementary. And the last property that we should have noticed from the sketchpad activity is that in a quadrilateral that is a parallelogram, we're going to find that diagonals bisect each other. So we know that the diagonals of our parallelogram are the segments that connect non-consecutive vertices. So QS is a diagonal and PR is a diagonal. What it means by them bisecting each other is that they're going to split up each other into 2 equal pieces. So we notice that they intersect at point M, and so QM is congruent to MS, and similarly PM is congruent to MR. Now we can use all of these properties to help us solve for certain measures in a parallelogram. So let's try a practice problem together. This says that STUV is a parallelogram, and we need to find TU and WT. Well, looking at this, I notice that I am given the measure for SV and for VW. What I can say is since SV and TU are opposite sides, we know that opposite sides are congruent. So TU will be 12. Also, we have another property of parallelograms that says the diagonals bisect each other. So if this segment VW is 14, I know that WT will also have to be 14. And then we have solved for the 2 missing measures that they've asked for, which means we're pretty much done with our lesson and it's time for a joke. And our joke is, where does snowman dance? Well, snowmen dance at snowballs.